Today we are going to begin our first unit of the year. It's based on quadratics. It focuses on Chapter 4 material in your textbook. Today our goal is to cover the first section of Chapter 4. These are some things that hopefully you should be able to do. So at the end of this lesson, you should be able to graph a quadratic function, label the vertex and axis of symmetry. Use the vertex to find the maximum and minimum values of quadratic equations applied to real-life problems. So please make sure you write these I can statements down. I expect to see those in your notes tomorrow when I grade your notes and look at them and check them over for points. I expect these to be the first things I see. And also use them as a guide as you're going through the lesson. Okay, is this helping me in my mastering these two I can statements? Okay, let's get started here. First section is titled 4.1 Graph Quadratic Functions in Standard Form. First of all, what is a quadratic function? A quadratic function comes from the family of functions y equals x squared. We call y equals x squared the parent function. Why do we call it the parent function? Think about it in your own family. The parent, hopefully, are the head of the household. They're the ones that are in charge. They start everything. They're the most basic. I shouldn't say the most basic, but they are the head of the household. That's where it starts. Without them, there'd be no you. So that's kind of what's going to happen with quadratic functions. The most basic one is y equals x squared. We're going to build upon this basic model. We're going to have different variable or different coefficients in front of x squared. We might add or subtract terms from x squared, but this is why it's called the parent function. It's the most basic. The other function you've studied previously, I hope, is linear functions, and those are y equals mx plus b. When you learned those previously, but the parent function for that equation is y equals x. So it's basically the same idea as what you're already used to with linear functions. Some things about quadratics. Quadratics are shaped like a parabola. Parabolas. What do parabolas look like? Parabolas basically are U's. They can look like a regular U, or they can look like an upside down U. But those are the two ways we are going to shape quadratic functions. So when you see a picture of a U straight up or straight down, you know it's a parabola. And that's how you identify it from other functions when you graph it. Parabolas have some characteristics. One of those characteristics is the axis of symmetry. Okay? The axis of symmetry is the line that divides the graph in half evenly. It's the line of symmetry, symmetrical, so that everything's the same on either side of the line. That's what a line of symmetry does. So if I have a parabola here, it's drawn in the plane. If it's centered near the origin, it's supposed to be at the origin, but we're centered at the origin, then the line of symmetry for this particular graph would be the x-axis. Now, is that always going to be the case? No, it's not always going to be the case. But if it's drawn in the middle of your xy grid, at the origin center there, then the axis of symmetry will go right through the middle of it on the y-axis. So, that's the axis of symmetry. We also have this point down here at the bottom, and I kind of dotted in blue. I'm going to dot in green now just so it stands out. We call that the vertex. And the vertex is the high or the low point of a graph. It's the highest of high, the lowest of low. So vertex, you may also hear it in code as the max or min. They're very similar. Okay? The vertex and max and min, they go hand in hand. Okay? They're always an x equals value. We'll get more into that on the next slide. But here's just some basic properties. Parabolas or excuse me, quadratic functions. Okay, so we learned about the parent function of quadratics. Now let's get into what we're going to use most often, which is standard form of the quadratic function. At least for now, while we're graphing, we're going to use this form quite a bit. Standard form is of the form y equals ax squared plus bx plus c. Okay. Here's some things I want you to add to your notes. So you haven't already, I'm sure, but these are some points I'm going to highlight, so we'll have them for tomorrow when we go over some problems in class. The first thing I want to talk about is how the graph opens. Does it go up or down? I told you in the last slide, graphs sometimes open up, they sometimes open down. How can we tell that from the equation? Well, the graph will open up if A is greater than 0, or if A is positive. Well, where is A coming from? It's the same A as up here. Okay? It's the same A in front of x squared. So if A is positive, the graph will open up. It'll look something like this. It's like a smiley face. Okay? Conversely, I'm sure you're all guessing this right now, if the graph opens down, if, you got it, A is less than 0 or negative. Same A, so if A is positive in front of x squared, it goes up. If A is negative, it goes down. And so it'll look like a frowny face. Okay? The other thing is how the graph stretches or compresses. Okay, what do I mean by that? Well, what makes it get wider or narrower? Well, the graph of y equals ax squared plus bx plus c is narrower than compared to y equals x squared if what? Well, if the absolute value of A is bigger than 1. Remember, absolute value, that's what these lines mean next to A, these straight up and down lines. Absolute value always makes the value positive. So what it's saying, whether it is a positive A or a negative A, the absolute value of it is bigger than 1, then the graph is going to shrink. It's going to, the sides are going to get closer together. Okay? The graph of y equals ax squared plus bx plus c is wider if, it's a little bit harder one to guess, not really, the absolute value of A is less than 1. Okay, so if we get a fraction or decimal less than 1, whether it's positive or negative, it's going to make the graph wider. It's going to stretch the boundaries of that. Let's look at that a graphing calculator, see what I mean. Let's graph some examples of that. So I'm going to bring my calculator up here. If we want to graph something on the graphing calculator, let me see, put it on a large screen so you can see that as well. You've probably done this before. First, we have to go to y equals, and you may or may not have a graphing calculator with you at home. But this is just something to see, so when we come to class, we can practice that. And I do strongly suggest if you can, borrow one or ask one for birthday, Christmas. Christmas is a while from now, but sooner than that, if you can get a graphing calculator, that would be awesome. But let's see, let's look at y equals x squared. Here is the parent function when I graph it. That's what it looks like. You going through the center. If you want to, you can look at the table. The table, if you get seconds in graph, it gives us second. Hit it. Second in graph, that gives us a table. We can see some inputs and outputs in our graphing window. I don't like the way this table is set up, so if I hit second window, you'll see in your calculator it says table setup. And we want our table to start at 0, but I want my change in table, that's what that triangle means, change in table values, aka the intervals, to be 1. And so now when I go back to my table, I can see some nicer values. And it also produces negative values as well. So if we notice something, that's why the symmetry line goes through the origin for this one. The outputs are 149, 149 as we go positive or negative direction. They're the same. Hence, that's where the line of symmetry comes from. So here's the graph of y equals x squared. Let's look at some where the graph opens up. The graph will open up. Let's just put y equals 3x squared. We graph it. It opens up, and we also notice that it got narrower. It got narrower, and that makes sense because if we follow along with the point we have, the graph of y equals x squared plus bx plus c is wider if it's less than 1, but greater if it's greater than 1. And you can see from the graphing here from our equation that 3 is obviously bigger than 1. Okay, let's look at one that goes down. How about negative 0.5 x squared? I'm just picking some here just so you can kind of see the picture. It goes down, and you notice from the original function, it goes down now, and it got wider. So that's just giving you a little visual of how the A's can change with the way the graph goes. Okay? Okay. There's a couple more points after that. The axis of symmetry. When we start trying to find this, we have to find it or sometimes from the graph, graphically, but a lot of times you're going to find it from the equation. You're going to find it using an algebra equation. The axis of symmetry can be found using the equation x equals negative b over 2a. You're saying, where does a and b come from? Well, a and b are going to come from the form y equals ax squared plus bx plus c. This is where a, b, and c are coming from. So we're just going to compare our equation in standard form, take out a and b, and simplify this fraction. That's going to give us the axis of symmetry. Remember, that's that line that splits the graph in half right down the middle. We also are going to have to find the x-coordinate of the vertex, okay? And the vertex in general. The x-coordinate of the vertex has a formula as well. And you're thinking, oh man, another formula. But lucky for you, it's actually the same formula as the axis of symmetry, which makes sense. The axis of symmetry has to go through the vertex, so they should have the same equation. Okay? And finally, one last cool thing we can learn from this graph, or from the graph or the equation that applies to the graph, is the y-intercept. The y-intercept is where the graph crosses the y-axis. So the y-intercept is 0, c. So that's another point when we have to graph this that's going to come in handy here in a few minutes. So make sure you have these all down. So tomorrow, if you don't have a graphing calculator at home, you can't practice this at home. You hopefully have taken the notes and paying attention and get going with some hands-on practice tomorrow. Okay. First example. A lot of background information, but this is probably relatively new to most of us, so we kind of need that stuff first. But here's applying it. Find the vertex and axis of symmetry and graph the equation. That's what I'm going to ask you to do on your homework problems or your in-class problems tomorrow, on the quizzes coming up, tests. So this is just something that you need to know how to do. These three things. You should be able to look at an equation and give me these three pieces of information. Okay? So first of all, let's take a look and identify this. This is of the form y equals ax squared plus bx plus c. That's just like that general form. Okay? So what I like to do is I like to identify what my a, my b, and my c are right off the bat. Because I'm going to need those pieces of information as we go through to identify all these pieces. A, well, that's what's in front of x squared. Now, don't tell me a is 0. That's a common mistake. Remember, that there's a variable there, and you don't see a number. Its default coefficient is 1. That's 1x squared, so a is 1. You don't see a 1 there, but it's really tiny, and it is there. B is -2. Some people forget about the negative sign. Don't ignore it. The coefficient, if it's a subtract 2x in this case, then b is -2. And c then, the same line of thought, is -1. So we identify our a, b, and c. Before we even graph this, before we even put it in our graphing calculator, we should conclude what direction this graph opens. Does it open up or down? Well, what's the rule? Look back at your notes. If a is positive, then the graph opens up. A is positive, so it opens up. Because a equals 1. Okay? So that should be something to say, okay, this is a U, this is a smiley faced U. It opens up. Okay? Let's find the vertex and the axis of symmetry. So the vertex, how do we go about finding that? Well, on the last slide, we said the vertex and axis of symmetry both have the same equation. Okay, the vertex / axis of symmetry, they both went x equals -b over 2a. What is my b and what is my a? Well, my b is -2. So I'm going to take b out and put in a -2. Now, notice there's already a negative sign in front of b, so we have to, it always stays here, that first negative sign. If b is negative, it's a double negative, and it's going to turn into a positive here in a minute. A is 1. So I like to put these in parentheses, so when I plug in, I put in parentheses. And now we simplify it. Minus a -2 is +2. 2 times 1 is 2. 2 divided by 2 is 1. So I've got a couple things here. One, I've got the x-coordinate for my vertex. It's 1 something. And I have my axis of symmetry, which is x equals 1. So I know, if I go to my graph right now, I know that at x equals 1, I'm going to dot it because it's not really on the graph, but there's this imaginary line that kind of just splits the graph in half. And my vertex is going to be somewhere on that line. How do I pinpoint it down? Just having the x-coordinate of the vertex is not enough. I need to have a y-coordinate as well. How do I get a y-coordinate? Well, I can get a y-coordinate by plugging our x-coordinate into the equation and solving for y. Our original equation is y equals x squared minus 2x minus 1. So I'm going to write this down. Y equals x squared minus 2x minus 1. And what I'm going to do is I'm going to take this x equals 1 and I'm going to plug it in everywhere I see an x. So y equals 1 squared minus 2 times 1 minus 1. And now I can just use order of operations. I can use my graphing calculator, scientific calculator. I can calculate this. 1 squared is 1. 2 times 1 is 2 minus 1. And now they're all addition and subtraction. In this case, it's subtraction. So I go left to right. 1 minus 2 is -1 minus 1, which is a -2. So the y-coordinate for the, vertex is -2. So I'm going to plot that point on my graph. I know that over 1, down 2, that is the bottom of my graph. All I need now is a point on either side, and I can graph this equation. Okay? Well, remember, when we're in standard form, one of the keys I gave you on the other page was the y-intercept. The y-intercept is a very easy point to graph because it's just 0c, whatever c is from our equation. Well, what did we say C was? We identified C to be -1. So if C is -1, I know that my y-intercept is 0, -1. So I'm going to go up to my graph. I'm going to plot 0, -1. And here's the thing, because we know that it's symmetrical, I can reflect this point over the axis of symmetry, and so I know that the point 2, -1 is also on my graph. And now I can just make a U shape, and we're done. And that's how I would expect you to graph this equation by hand. One point on the other side of the vertex, the axis of symmetry is labeled, the vertex is labeled. You want to go for gold here, maybe on the graph. I know you have it in the notes already, but on the graph, you label 1, -2 as the vertex, x equals 1 as the axis of symmetry, and this is good as gold problem. You might be asking yourself, Mr. Kuhn, can't we do this on a graphing calculator? Yes, you can. I'm showing you this way because if you go home and you say, I want to practice this, but I don't have a graphing calculator, this is how you have to do it. If you have a graphing calculator, and I'm going to show you right now, this becomes even easier. So I'm going to go to y equals. I'm going to clear out everything. And I'm going to type in x squared minus 2x. Oops. Wrong place, at y equals. That's what I thought it was. Well, x squared minus 2x minus 1. Sorry about that. You have to go to y equals first. So I put that in the y equals equation. I hit graph. And let's see what we get. And I have this cool feature of mine. I'm going to drag out my equation. It looks pretty similar to what we had, doesn't it? Okay. But it's not going to be good enough to be able to just put it on the calculation. You have a multiple choice test. If I asked you to do this by hand, you can't just scribble a U on there that looks about the same. I need points labeled. So the graphing calculator, don't get too frustrated, will help you with that as well. How do we get points to label on a graphing from a graphing calculator? We go to the table. If you hit second graph, and notice since I have the graph, I find where my axis of symmetry is. My axis of symmetry, which we've already calculated, is 1, -2. And a lot of times the problem's going to ask you for axis of symmetry and vertex anyways, so you calculate it by hand, and so then you have no good idea where to start on your table. And now I have an XY table. I can just pull these values off to the side, and now I can plot any of them I want. I already plotted 1, -2. That's in the middle. 2, -1. 0, -1, we plotted those, but there's additional points. So if you're in a class, I'm only asking you to do it by hand, 1 point on either side of the vertex. Or maybe next year in pre-calculus, or down the road, they want you to have 5 points on each side. Here's an easy way to get as many points as you want. Infinitely many points. Okay? And if your vertex is a fraction, remember, you can always go to the second window, and we can start our table at whatever value your vertex starts at as well. And you can make it go up by fractions, by decimals. It doesn't always have to go up by ones. So keep that in mind as you're practicing these problems in class. Okay, let's do one more example just because I know it helps to have more than one example or see this more than once, although you could rewind this as many times as you want. If you missed something, pause it. Please do. This is the advantage of being in class. You can go as fast or as slow as you need to with this. Y equals -x squared plus 6x minus 8. That's our next equation. We're going to do the same 3 things we did in the last problem. Find the vertex, the axis of symmetry, and we're going to graph the equation. Okay, so this negative sign in front of x squared, that tells us the graph opens which way? It opens down, that's right. It opens down. That negative sign tells us the graph opens down. And I skipped right by it. I said I like to identify these points first, so let's go back and do that. Our A value, it's a -1. It's not just negative. Remember, there's a 1. You don't see a number, then it's a 1. B is 6. I know my 6's and B's kind of look similar, but I try and curve them. So B is 6 in this case. And C is -8. So we're going to go through and we're going to find our key values, our axis of symmetry, and our vertex graph and plot the points. Okay, so axis of symmetry. The axis of symmetry is still x equals negative b over 2a. b is 6, so minus 6 over 2 times negative 1. Negative 6 on top, 2 times negative 1 is negative 1. Negative 6 divided by negative 2 is positive 3. So I know that my axis of symmetry is x equals 3. That's my dividing line. So we need the vertex as well. Vertex, we're halfway home with that because the vertex is the same as the axis of symmetry. So we know that our vertex is 3 some number. How do we get y? Think about it. What did you do on the last problem? On the last problem, we plugged in x for y. So I think we're going to do that again. It sounds like a good plan. So that was our equation, y equals negative x squared plus 6x minus 8. So I'm just going to take 3, plug it in for x, and make sure you're putting it in parentheses because it gets tricky, especially when the coefficients for these x's are negative and you're due to taking in some power. So when you go to plug this in your calculator, you want to make sure you get the right answer. Okay, last time I did by hand, this time let's practice on a calculator. I'm going to put that exact value in. So I need to be on the regular part of this. So I'm going to put in negative 3 or minus 3 squared. And that's key because if you put the negative without the parentheses, it's going to give you an answer you're not going to like. I put it all in at once. As long as I type everything in correctly, it does the order of operations for me. And I get y is 1. So when I plug this all in, I get y equals 1. That's just another way of finding the y-coordinate of the vertex using your calculator. I'm going to show you another way here in a minute, which maybe some of you know already. If so, x equals 3. And I just realized x equals 3 line goes through x equals 2. So let's try putting that up the correct way. 2, 3. Didn't count over far enough. My fault. But I corrected the mistake, so it's still okay. So let's plot 3, 1, which is right here. Here's my vertex. We know it opens down, but we need points on either side. Remember, the easy point to find or to use is the y-intercept. The y-intercept, remember, is 0c. Our c value from this problem is negative 8. So 0, negative 8 is a convenient point to plot on our graph. So we're going to go put 0, negative 8. 0, negative 8. I'm going to count this time. 1, 2, 3, 4, 5, 6, 7, 8. I got it. And now remember it's a symmetry line in the middle here. So if I just count in 3 places to this symmetry line, so I count 3 lines over, and I have 2 points on either side. And I've graphed this by hand. I've labeled it. I've labeled the axis of symmetry. I've labeled the vertex. And I've got a point on either side. We've successfully graphed this by hand. What if I want to graph this on the graphing calculator? I sure told you I promised some bonus information here as well as to find values on the graphing calculator. Let's do both of those. First, let's clear out that old equation. Let's put in the new one we're dealing with now. Just got to type in the calculator. And when we graph it, a lot of times this is just a quick check. If you can look at it and you say, wow, that looks pretty close to what we have, because my grid is not exactly the same as the grid on the calculator, but I'd say it looks pretty good to me. Okay? Over 3, up 1, as the vertex is pointing down. My y-scale doesn't go down far enough, but it sure looks like if I extended it, it would go down to 8. It's looking pretty good here to me. Okay, but what if you need more points? You want to double check. Do I have the table correctly? Hit second table. We're going to center it at the vertex which is 3, 1. So put 3, 1 in the middle. We can see it's very symmetrical all the way down. So here's some more values if we wanted to. Where can I fit this in here? If I wanted to put this in, oops, we'll slide it down here a little further. So lots of ways to get your XY values. You can also, one other thing, if you're trying to find the axis, we found the axis symmetry, trying to find the y coordinate of the vertex. Here's a little cool thing you can do. Okay, on the graphing, on the calculator, if you push second and trace, you see calc in little blue letters. There's a bunch of things up here, and then we're going to do a lot of those functions and show you how to use them eventually. But right now, if we want to find the value, we know that the x coordinate of the vertex is 3, so you put 3 in, and it tells you y is 1. That's pretty cool. So that's another way you can get any value. Let's say you want values on either side. You hit second calc and value, say, okay, well, if it's 3, then let's find out what 2 is. When we plug in 2, we get out 0. So this is like making your own table by hand, what you would do if you're making your own table, using order of operations to find the values, but the calculator do it one value at a time for you as well. It will also, as you can see, make a bunch of tables or a bunch of values at once in the table function. So whatever is easiest to you. I am just showing you the information so that you have the ability to do it any way you want. And that's really all I'm worried about is you picking one way and going with it. Okay, what can the graphing calculator do? So the graphing calculator, and we're going to get these equations out of the way. We've used those already. What can it do for us? So let's think about things we can do with the graphing calculator. You can graph with it, obviously. So we can graph. How do you do that? You hit the y equals button. So that gets you to graphing, the y equals button. Let's put the word button here so you know what that means. We can look at a table of values, which is second, and then graph. And we can find the vertex maximum minimum. And we didn't show you that way. But we can do the vertex by doing second and trace. And that will give you the max min. And when we looked at the graphing calculator on the last one, second trace, if you go down, we have minimum and maximum. Those are the keywords for vertex. On our graph, you can see there's a picture down here in the middle. The graph points down. So the point at the top here is going to be a maximum. That's a maximum value. So we go down to maximum, which is 4. If it opened up, then it would be a minimum value. When we choose that, it'd be the same directions. Okay, it says left bound here, so we're left of the vertex. The vertex is in the middle. I just hit enter, and then it says right bound. I arrow over to the right, just as long as I'm to the right of the vertex. I hit enter. The two arrows are pointing at each other. What that does is you've told the calculator, look between these two arrows to find the maximum value. To do that, I hit enter one more time. And I get 2.99999 and y equals 1. Well, 2.99999 is pretty close to 3. It's just a rounded value. The more accurate the value will be, the closer you get those arrows to be together. So the closer you can get to the vertex without being on the vertex, the better for that method. So that's just another way to, technologically, I guess you'd say, find the vertex. Okay. So, wrapping this all up, and we can see, hopefully, looking back at your I can statements, in this case I should be able to, but I can statements, it's the same idea. You should be able to graph a quadratic function, label the vertex and axis symmetry. I think we covered that. Hopefully you feel more comfortable with it. By the end of tomorrow, you should be mastered at it and practice in class. We also discussed at the end how to find use the vertex to find maximum, minimum values of a quadratic equation. Okay, we're going to apply that more when we get to the problems in class tomorrow. We'll do some story problems. They'll have us finding max and min, which is just basically code for finding the vertex. So, if you missed anything or you have any questions, come to class prepared. But please feel free to fast forward and go through any part of this lesson you need to watch again. We'll see you tomorrow.